In this lesson, we shall focus on mathematics, parametric curves. In 7a, we will sketch the curve by eliminating the parameter t, indicate the curve's orientation. Right, so given x equals the square root of t, y equals to t plus 4, t in r, right half of the parabola, y equals to x squared plus 4, traversed upward, sketch the curve. Right, how do we sketch the curve? Right, to sketch the curve, we will actually make use of a couple of things. Right, so obviously we need to sketch, but the way we sketch it, you need to sketch the curve by eliminating, we need to eliminate the parameter t. So at this point, we are able to see that we have been given y being the square root of t, simultaneously y equals double t plus 4. If you square both sides, you will have exactly this, meaning x squared is t. All right, let's see. Okay, good. First and foremost, to discuss this notion of parametric curves, you need to understand that parametric curves, first and foremost, what we call parametric curves, right, are curves written as functions of t, written as functions of t. Okay, so you square, you get that. Y equals twice t plus 4. So if you call this one equation 1, call this one equation 2. You'll then go on to then say substitute, right, substitute equation 2 into equation 1. Meaning you have 2t plus 4, which is 2x squared plus 4. We've eliminated the parameter t. The first step is to eliminate the parameter t. We'll sketch the curve by eliminating the parameter t. We've managed to eliminate it because there's no t anymore here. No t anymore. Okay, it's a very easy topic, so you don't have a lot of background here. You don't have a lot of detail, because it's just basic algebraic manipulations of this. And then now, how do you sketch the parabola y equals 2x squared plus 4? When x is 0, y becomes a 4. When x is 0, y becomes a 4. And then you'd have exactly this. You'd have exactly that curve there. So that becomes the graph. To x squared plus 4. Any question on this one? Right. Okay, but remember that x is this, so x is greater or equal to 0. So you need to remove one part. You need to remove this part. Sketch it only on the part where x, because as much as t is a real number, t is a real number, but x is the square root of t. So x being the square root of t means x is greater or equal to 0. means x is greater or equal to 0. So x greater or equal to 0 means you have this. So, and because of this, then it becomes the right half of the parabola. Right half of the parabola. Right half of the parabola. Any question? Right, think about it and make sure you understand it. Let's look at the next question. Once again, because it says right half of the parabola, it's on the right because this side is the left half, and this side is the right half. Is the right half. Becomes the right half. So move on to the next thing. Sketch the curve by eliminating the parameter t, indicate the curve's orientation. So you have x equals 2 cosine t, y equals 5 sine t. 2 cosine t, y equals 5 sine t. Once again, it's a very easy topic, so you don't have a lot of background that's necessary. Okay, good. What does transverse upward mean? What does transverse upward mean? So it is actually the curve y equals 2x squared plus 4, as we can see 2x squared plus 4. But transversed upward means that obviously it is sketched to be such that when x increases, y also increases, and therefore it is traversed. And by the word traversed, this is to do with being traced or drawn upward. Right, it is traversed upward because it actually traces its path upward. Traces its path upward. Traces its path upward. Because when x increases, y also increases, so it's an upward graph. It's an upward graph. Okay, let's move on to the next thing. Let's move on to the next thing. Okay, now sketch the following by eliminating the parameter t. So you're going to eliminate the parameter t. So how to eliminate the parameter t? These are like simultaneous equations. T between 0 and 2 pi. Simultaneous equations. Simultaneous equations in terms of t. So you can divide by 2, having x over 2 equals cosine t. And then y out of 5, you divide by 5 equals sine t. X over 2 squared. If you square this one, you get cosine squared t. Y out of 5 squared becomes sine squared t. So that now this one becomes x squared out of 4 is cosine squared t. Then you have y squared out of 25 is sine squared t. X squared out of 4, y squared out of 25 becomes cosine squared t plus sine squared t. And this is equal to 1. As a consequence, it means that whenever you have x squared out of 4 plus y squared out of 25, it is actually equal to 1. Okay, what kind of graph is this? It is this one when x is between 0 and 2 pi. Can x be negative? Yes. Can y be negative? Because the cosine can be negative, so x can be negative. Because the sine can be negative, the y is negative. Whenever y becomes 0, so you'd have x squared out of 4 equals 1 whenever y is 0. This means that x is plus or minus 2. In the same way, whenever x is 0, y squared out of 25 equals 1. That means y is plus or minus 5. So now this would be 1, and therefore y is plus or minus 5. Okay, so plus or minus 5. And then x is plus or minus 2. And therefore, you have this. You have exactly this. You can draw it properly. And try to draw it nicely. And draw it nicely. Can draw it beautifully. This is y and that is x. Right, so this one here is an ellipse. Okay, there's something I want to say about this one. There's something I want to say about this. As said already, it is actually traversed upward because x would start from the origin. So x is going to be greater or equal to 0. So x should be 0 here, and x is greater or equal to. So also, it becomes so necessary to put an arrow on the curve you can put it in the middle of the curve to make sure that it is traversed upward, and because it's traversed upward, beginning from x greater or equal to 0, it will therefore be having an upward arrow on it. An upward arrow on it. So that is something that you need to take note of. Okay, so if you look at this one, same thing. Now, at this point, our t is greater or equal to 0, but t runs from 0 to 2 pi. So when t runs from 0 to 2 pi, what's going to happen with this? There are times when, okay, there are times when, for example, you're going to have that when t is 0, you'd have that y becomes what? Sine 0, which is 0. And then t goes to pi over 2, like 90 degrees. And sine of pi over 2 is 1. So this runs from 0 to 5. So you can see that y, therefore, is going to run from 0 to 5. So right, so this graph is going to be like this. It's going to be anti-clockwise. It's going to have what you call an anti-clockwise orientation. So it's going to be having that anti-clockwise orientation because as t runs from 0 to 2 pi, y increases. and at the same time, x decreases. How do we see that x decreases? Well, you need to substitute some values. Like the t runs from 0 to 2 pi. Right, so you have t runs from 0 to 2 pi, so you have x equals 2 cosine t, which is 2 cosine 0, which is 2. Which is 5 sine t, 5 sine 0, which is 0. Okay, and this is going to happen when t is 0. There's another step where t is pi over 2, just halfway. Taking in a 90 degrees. Just if you take a 90 degrees there, just in the middle, or just somewhere between 0 and 2 pi, not exactly in the middle. Okay, so you're going to have that, for example, your x is 2 cosine t, which is 0, 5 sine t, which is 5, the sine of pi over 2, 0. So now, what you're going to have? So what you're going to have is that, the sign here is going to be 5, because sine pi over 2 is what? Sine pi over 2 becomes 1. So you have 5. Let us check what happens when t 0 is 0. X becomes 2, x becomes 2, and y is 0. This is the point. X is 2, y is 0. And then now, when at pi over 2, this is at t equals 0. T is sort of the angle. The angle now becomes pi over 2, and then you have that x becomes 0 and y becomes 5. And y becomes 5. When y becomes 5, it means what? You can see, therefore, that the graph runs from this point to this point. So it has an anti-clockwise orientation. Anti-clockwise orientation. Any question on the anti-clockwise orientation? Any question on the anti-clockwise orientation? Okay, make sure you understand it, that it has an anti-clockwise orientation. So it goes against the clock. Goes against the clock. It goes anti-clockwise because the clock runs from 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. But this goes in the opposite. It goes in the opposite. Okay, so let's look at the next question. So this traverses what we call an ellipse. Right, it is an ellipse. So we're going to discuss some of the basic shapes that you can get. Right, a parabola we've got. So this one here becomes the right half of the parabola, because given by this is a parabola in the form y equals x squared with bx plus c. It's a parabola. The parabola, but this one is the standard form. It's the standard form of a parabola. It's the standard form of a parabola. Okay, let's move on to the next thing. I want us to focus on the next. Okay, let's get the next question. Okay, now we're looking at 7b. Let's look at 7c. Sketch the curve by eliminating the parameter t. Indicate the curve's orientation. Same thing. You given x is 3 plus 2 cosine t. Y is 2 plus 2 sine t. Cosine t, 2 sine t. And then you continue to look at this, and then you square both sides. You square this one, you have 2 cosine t, you square this. Y minus 2, you square this, and you have 2 sine t, and you square this. And then you have x minus 3, you square this, you square 2, you get 4 cosine squared t. 4 sine squared t. Y minus 2 squared is 4 cosine squared t plus 4 sine squared t. And then you pull out the 4, you have cosine squared t, and then you have sine squared t. X minus 3, you square it. Y minus 2, you square it. X minus 3, you square it. Y minus 2, you square it. The cosine squared t plus, sine squared t is 1. So this gives us this here. So this is a circle. This is a circle because it's actually of the form x minus a squared, y minus b squared equals the radius squared. So we're going to sketch a circle. We need to sketch yx. So the center is x is 3, y is 2. Like this circle has the center A, B. So x is 3 and y is 2. X is 3 and y is 2. Right, so x is 3, y becomes 2. Okay, so at this point, if x is 3 and y is 2, what then do we have here? You then have a circle of radius. Yeah, but the center is that in the radius. And there's a radius. What is the radius? Right, so the radius is r equals the square root of 4, which equals 2 units. Okay, so the radius is 2 units. So the distance, you measure 2 units. You get here. Like 2 units here. 2 units up. It's going to be at 4. But now you have here 2 units back. It's a 1. 2 units there becomes a 5. And then you have this. You have this. Okay, so this becomes a circle. Right, so the radius is 2. So you measure 2 units, but if from here you are at 2, you measure 2 units, you'll come to here, 0. And then you have 2, you add 2, you get 4. You have 2, you move 2 units, so that's going to be 3 minus 2, giving a 1. 3 plus 2, giving a 5. Now, the couple of things you need to take into account. The fact that you need to sort of traverse these anti-clockwise. So what happens where t increases from 0 to 2 pi? T increases from 0 to 2 pi because at 0, cosine 0, t equals 0. X becomes 3 plus 2 cosine 0, which is a 5. 2 sine 0, which is a 2. Let us take some other next angle. Maybe we take pi over 2 radians. So you'd have that x is 3 plus 2 cosine pi over 2 radians. And cosine pi over 2 becomes a 0. And this gives us a 3. Y becomes 2 sine pi over 2 radians. And this becomes a 2. Well, it becomes a 4. Because cosine pi over 2, that cosine 90 degrees, 0, giving us a 3, and this one is 2 plus 2, giving us a 4. Obviously, at this point, you need to pay particular attention to this, but also see to it that you are able to understand these things. So you then be able to get the following. What happens to x? X was 5 before, but now x became 3. So you can see a decrease in the x because x was 5, but it became 3. So as t was increasing from 0 to pi over 2, x was decreasing. Y was 2, and then y became 4. So you can see, and actually the y is becoming bigger from 2 to 4. Y is becoming bigger. So in other words, this is that y is becoming bigger and bigger. So y is becoming bigger, so it's going up. So it is traversed in the anti-clockwise direction. It has an anti-clockwise orientation. There's an anti-clockwise orientation. There's an anti-clockwise orientation. There's an anti-clockwise orientation. Anti-clockwise orientation. Any question? Any question? Any question? Any question? So we are moving on. We are moving on because you can see that it's traversed anti-clockwise. It goes against the clock. It goes against the clock. Okay. So move on to the next question. Okay, let us look at 7 right now. Sketch the curve by eliminating the parameter t, indicate the curve's orientation. Same thing. So you'll have to look at what happens in this case. Let's reason together. Sorry, let's reason together. So the way we reason, we take into account a couple of things. X is cosine t. Y becomes sine t. So, right. Right. Okay, let us reason these together. And now we go back to metric. We go back to the metric clause and we say cosine 2t. We know that cosine 2x. Normally we use x at metric. It's the same as cosine squared x minus sine squared. Which is 2 cosine squared x minus 1. 1 minus 2 sine squared x. So which means that this is 2 cosine squared x minus 1. Y is the sine of t. 2, and then it is y squared minus 1. Because you substitute, let's see what you're getting here. Yeah, it is that, but you need to do the other way. So cosine 2t becomes, we're going to use this one, the bottom one. So you can use 1 minus 2 sine squared t. Because we know that sine squared t is y. So it is y squared. Y becomes sine t. Y becomes sine t. Right, so now at this point you need to sketch this parabola. This is a parabola. It's a clear parabola because whenever y is sine t, you put it here in the place of sine t, then it is y. You have a y squared here. When x is 0, when y is 0, this thing goes away and then x becomes 1. So you're going to have x1. When x is 0, 1 equals this. When x is 0, so you're looking for the y-intercept. That's right. So you're looking for the y-intercept. Let x be 0. Which means 2y squared is 1. plus or minus 1 over the square root of 2. So y becomes therefore negative, positive. So okay, so we have this. So if you look at this graph, but let us look at what happens whenever we are looking at this interval. Minus pi over 2t pi over 2. When t is minus pi over 2, you'd have x is cosine 2t, y is sine t. Cosine minus pi over 2, you cancel this and it becomes minus cosine pi, which is minus 1. Which is sine t, the sine of minus pi over 2, which becomes minus 1. And then whenever t is, you can take 0, which is sort of midway between the negative and the positive angle. So you'd have x equals the cosine of 2t, which is the cosine of 2 by 0, 1. Y equals the sine t, which is the sine of 0. Sine of 0 is 0. But what happens whenever t is pi over 2 at the end? You'd have that at pi over 2, you'd have x equals cosine 2 pi over 2, which is minus 1. Because it's the cosine of pi. The cosine of 180 degrees is minus 1. And then you're going to do the sine of pi over 2. And this is exactly what? It's a 1. So you can see that it runs from, at minus pi over 2, it runs from minus 1 to, it is from this one to this one, minus 1 at the end point. So let us reason these together. Let us reason these together. You see, whenever t is minus pi over 2, you'd have therefore that you have minus 1. Where do you have that both x and y are negative 1? So you have that x is negative 1, and then y is negative 1. So we are here. Right. Right. So you'd have this one, minus 1. Minus 1. So now if you have minus 1 is this one. So then it's going to run to x is minus 1 and also y is what? y is 1, x is minus 1, and then y is 1. It's somewhere here. Okay. Right. So you're going to have the following. So you're going to have that, it's going to run like this, and then it's going to run all the way. So it's going to run from -1, -1 to -1 and 0. But now it's going to sort of traverse. It's going to traverse the other way. So it's going to traverse from -1, -1 to -1, 1. Okay. So yeah, this is the graph. But also I need to mention here that these particular graphs here would actually be, you see, like this one, it's a full circle. Because the parameter, the angle is like a full revolution. So this would be like a full circle because it's like from 0 to 2 pi. From 0 to 2 pi. So at this point, x is, because 0 is like here for the circle, and then you go like this. So when x is 5, y is 2. Then you go the other way. But if you have this one, so you're going to have at this point, this one, it's similar, but it said it's traversed. But the question is, where does it end? So it runs on and on and on and on whenever t is a real number. So t will run, t would be greater or equal to 0. So in other words, you can look at t as an element of the interval from 0 to infinity. So it's going to go up to infinity like that. It's going to go up to infinity like that. You see? So, so look at it and think about it. Look at it and think about it. Let's look at the next question. So now, you see, you'd have this circle that is like that. And so you traverse it this way. You traverse it this way. So now, also this one is it's our parabola. This parabola allowed us to get the y-intercept. which we get by saying let x be 0. When x is 0, then we get the y. Now, as soon as you can get the x-intercept, and then you have to let y be 0. So now, 1. X is 1. Okay, so when x is 1, so now this is what we're getting. It's what we're getting. Okay, any question? Any question? Any question? Right. Any question? So now I'd like us to look at the next thing. Right. Okay, yeah. So let's look at the next question. Okay, if you look at the orientation of it, it is, once again, the description is we have a parabola from that to you have a parabola from -1, -1 to -1, 1. Okay, so that's what you have. So yeah, I'll continue. Now, okay, let's look at this one. Sketch the curve by eliminating the parameter t. Okay, so we do this is like trigonometry. It's trigonometry. So you have sec squared and then 10 squared. So you need to look at what these functions have for you in terms of identities in trigonometric laws. So you deal with, first, everything starts from sine squared t plus cosine squared t equals 1. Divide by the cosine squared over cosine squared t over cosine squared t, 1 divided by cosine squared t. Divide by cosine squared t throughout. getting a tan squared t plus 1 because cosine squared of a cosine squared is 1, and then 1 over cosine squared becomes the secant squared. Okay. So that's what you're going to do. You know that tan squared t plus 1 becomes the secant squared t. So what is tan squared t? Tan squared t is y plus 1. What is secant squared t? It is x. So this is sort of the thing. At the initial point, at t equals 0, you have x equals the secant squared of t, and then y equals the tan squared of t. Secant squared 0, tan squared 0, and then at pi over 3. So now, at pi over 3, you have sec squared t, and then y equals tan squared t. Sec squared t and then tan squared pi over 3. Okay. Secant is 2 squared, 4. The secant of pi over 3 is like 1 over cosine 60. Cosine 60 is 1/2. But this one is 1 over that. So if cosine 60 is 1/2, then the sec is 2. It's like 1 over 1/2. And then you have this one, pi over 3, pi over 6. Square root of, okay, 2. 2 square root of 3, 1. The tangent of pi over 3. What is the tangent of pi over 3? SOHCAHTOA. And then now the tangent becomes opposite of adjacent. Opposite pi over 3 of adjacent, which is square root of 3. So, okay. So you can see it runs from x1, y0 to, so it is from these two, x is 4 and then y is 3. Okay. So what kind of a graph is this? Y-axis and then x-axis. What kind of a graph is this? So it's a straight line. Whenever x is 0, y becomes -1. Whenever y is 0, x is 1. And then you'd have a straight line like this. Okay, with the intercepts. But it's going to run from 1, 0, x is 1, y is 0, to 4, 3. Okay. To 4, 3. So you're going to be 1, 0 to 4, 3. So 1, 0 to x equals 4 and y equals 3. So this is like a straight line. But this straight line is going to run like this. So it has this, it's traversed like this. It's traversed like that. So you can just write initial to final point and then show the traverse direction. So obviously it's traversed upward from 1, 0 to 4, 3. Any question about this? Any question about this? Any question about this? Any question about this? All right. Any question about this? Any question about this? Okay, or any question about this? Okay, in absence of a question, then you move on to the next thing. In the absence of a question, you move on to the next thing. You move on to the next thing. You move on to the next thing. Okay, let's look at the next question. Is there any other? Let's look at question F. Let us look at question F. Question F is the same thing, right? So if you look at this previous one, see now. So you know that this one is a straight line. It's a straight line. X equals y plus 1 or 1 plus y. But it is from 1, 0 to 4, 3. From 1, 0 to 4, 3, that is how it is traversed. 1, 0 to 4, 3, that is how it is traversed. So let's look at the next one. Let's look at the next thing. Okay, if you look at F, similar. So X becomes 1 minus 3 cosine t. Y equals minus 2 plus 2 sine t. Then you need to have x minus 1 divided by negative 3 is cosine t. Y plus 2 you divide by 2, it is sine t, and then you square everything because you want to get cosine squared plus sine squared, because you know very well that cosine squared t plus sine squared t is already 1. So here you have this one, you divide by negative 3, and then you square it. Y this, and then you square this, which is x minus 1, y plus 2, cosine squared plus sine squared. So now, we have y plus 2, cosine squared plus sine squared equals 1. And this thing here becomes what you call the, because it runs from this to this. So now you need to do, because t is 0, when t is 0, you're going to substitute here. 1 minus 3 cosine 0 minus 2 Okay, yeah. So you have t equals 0. Yeah, okay, yeah, the other one, the last one, pi. Pi is going to be 4 because cosine of pi is -1. And then this one is going to be exactly sine 0, which is -2. So the point is going to be -2, -2, -2, -2, and then it's going to go to x4, y -2. So it's sort of going to be from this one to that one. So the kind of graph you have here is, it is an ellipse in the upper half plane. It is an ellipse. So now it is at 1, 1 -2. X is 1 and y is -2. Okay, so if x is 1, y is -2, like this. X is 1, y is -2. X is 1, y is -2. Okay, so, okay. X is 1, y is -2. And then now you're going to mark some of the points, like -2, -2. You have -2 for y and then -2 for x. So there's a point here. And then here, whenever x is 4 and y is -2, x is 4 and y is -2. X is 4 and y is -2. Okay. There's something like this. What happens when um whenever, for example, in these, whenever x is 1, okay? Okay, whenever x is 1, y is plus or -2. Which means y is 0, y is -4. So whenever x is 1, you'd have those points. Any y-intercepts? whenever x is 0, okay, 9, which is 8 out of 9. So that y plus 2 squared is 32 out of 9, which is 4 the square root of 2 out of 3, plus or minus. So y is going to be plus or minus 4 the square root of 2 out of 3 minus 2. Yeah, so you have minus 2. So now you'd have the r. Okay, so you have this. Let us look at what this is going to be. Okay. Negative, negative, then there's a y that is going to be negative, like minus 2, and these, if it's 4 divided by 3 is like 1 point something, so it's minus 2 minus 1 point something approximately. So y is going to be like a minus 3. So that's going to be, it's going to cut at y equals minus 3, but also it's going to cut at the y equals the following. Let's use a calculator just to get a better sense. Okay. So now you have minus 2. So which is minus 0. 11 minus 0.11, which is somewhere here minus 0.11. And then the other one is going to be down there. So which means the graph is going to be like this ellipse, and then it's going to go also down. And then this ellipse appears to have no x-intercepts. Let us check. Let us check some x-intercepts. And to check x-intercepts, you let y be 0 in the ellipse. When y is 0, plus so now plus, and then when y is 0, it's going to be 4. It's like 0 plus 2. And then it's 2. 2 squared, it's 4. 4 over 4 is 1, which is this. Which means that it's going to have x minus 1 squared out of 9 equals 0. And whatever it means, x is 1. Okay. So whenever y0 is going to cut the x-axis at x is 1. At y0, x is 1. Okay, check this out. Let's make sure we reason this very carefully. Let us check this here. We check it out. We check this, we check this, we check this. So you then have a sketch of this. Okay. So now, so you're going to have a y plus 2 square, and then in the denominator, right, let's see. Okay, okay, we're continuing, and this person is calling me. Yes, please. All right, 2 minutes, 2 minutes. What time, what time? All right, okay, that's fine, that's fine. Okay, thanks. Right, okay, yeah, so you can see that it's gonna cut. So the graph, what it's gonna do is gonna sort of cut like this. Right, so it's gonna cut like this. Okay. Okay, I'm gonna show you now how it's gonna cut. I'm gonna show you now how it's gonna cut. Right, I'm gonna show you now how it's gonna cut. Okay. Okay, we're continuing. I'm just trying to respond to this person here. Just called me now. I'm trying to respond to this person just called me now. Right. All right. And then we are going on. So now we're going on. Okay, yeah, we're just finishing this question. Right, we're just finishing this question. Okay, let's go on. So now let us draw this carefully. So yes, it's going to cut, but it's going to cut at this point, and then it's going to touch the x-axis at 1. Going to come down like this. Okay, yeah, that is sort of the shape. You can see that it's going to have its x-intercept at at 1, and then it's going to go on like this. So it's sort of the shape. But is it going to come here? It's an ellipse, so it was supposed to also come down here like this. So now let us reason this together. We agree that because of this x, then it's sort of going to have bigger axis, and then the y is going to be small. So it's going to be like this. It's going to have this kind of a shape, like an egg that is lying down, but it's going to be traversed from -2 to 4 -2. -2 to 4 -2. Let's see, yeah. -2, x -2y -2 to 4 -2. So it's going to be traversed like this. So it's going to be traversed whenever t is 0, 0, then you have -2. Whenever it's 0, -2 to that. So it goes like this. It goes like that. It goes this way. Okay. So, any question? Any question? Any question? Right. So, any question? So, we continue to check the next question. So, you need to look at these very carefully. This is sort of an ellipse. Right. It's sort of an ellipse that um it's sort of an ellipse that has been drawn. It's sort of an ellipse that has been drawn. Any questions? So think about it. That was F. Okay, let's look at this one. Sketch a parametric curve, that one, where t is between -2 and 1 and indicate its orientation. Say the parametric representation of C with the orientation reversed. Right, so let us look at this one. Let us look at this one. Right. Okay, let us look at number 8. So we continue. Let us look at 8a. Let's look at 8a. Okay. Right. We continue. We continue. Now, the couple of things, obviously, that are important. So now, sketch the parametric curve, this one, and indicate its orientation. So to sketch it, you need to do a substitution and just eliminate t. How do you eliminate t? Doesn't matter the algebra you do, but you need to eliminate t. But from this, you can see that, for instance, y plus 1 is equal to t. All right, you can see that y plus 1 equals t. Call this one equation 1 and call this one equation 2. Then you then say, you substitute. Substitute equation 1 into 2. In the place of t, you put y plus 1. Squared plus 1. Which means x is y squared 2y plus 2. Solve. Okay. Whenever t is minus 2, you would have the following. Let us check this out. So you can investigate t equals minus 2 here because it's from minus 2 to 1. Right, so right. Okay. Whenever t is minus 2, what is x? According to this, x is t squared plus 1. So x is going to be 5 because it's going to be right. So we continue. Okay. Right. Okay. Right. So we continue right now. And we're going to have whenever t is minus 2, so you'd have so now you have the following. Right. So right. We are going on. We are going on. We are going on. Right. Right, we're going on, please. Right, we're going on. Okay, yeah. We're saying whenever our t is minus 2, which is 5, and then the y is minus 2 minus 1, which is minus 3. Whenever t is 1, t equals x equals 1 squared plus 1, which is 2. Y is 1 minus 1, which is 0. So you'd have 5 minus 3, 2, 0. So this is the initial point, and then this is the final point. Let us draw the graph. Let us draw the graph. All right, let us draw the graph. So we continue. So in the end, so you have this and this. Okay, so whenever t is minus 2, you have those, yeah? Let's sketch. So what kind of a graph is this? This is a parabola. The parabola x equals y squared plus 2y plus 2. Right. Then you have the following. Right. So we continue. Okay, this parabola is a special type of parabola that is either like this or like this, but you need to know that if ever the coefficient of the y is positive, that is going to have a minimum vertex. Right, so if it's going to have a minimum vertex, it's going to be actually such that, okay, just 1 minute. Right, just 1 minute. Right. Okay. All right, we're going on. Just 1 minute, 1 minute. We are going on. Just to sketch this one. So, yeah, we're going on, please. I'm just trying to communicate with this person here. Okay, let us continue here and check this out. So in the end, then, okay, we continue. All right, now continuing. You'd have a minimum vertex whenever y is positive. And then you'd have exactly the following observation, right? So minimum vertex means that it's going to be having this shape. Now, if it's going to be having this shape, whenever y is 0, x is going to be 2. And then it's going to obviously have this shape here, like this. Okay. Just that way. But you need to look at it very carefully because it's going to provide a shift. Going to provide a shift because y is going to be minus b over twice a minus b is going to be minus 2 over twice a, which is minus 1. So which means it is such that its line of symmetry is going to be at minus 1. But it's going to cut, very interesting, it's going to cut the x-axis here. But whenever y is this, x is going to be minus 1 squared, according to this. 2 into minus 1 plus 2, which is 1. So this is going to give us x is 1, y is minus 1. Going to give us x is 1, y is minus 1. X is 1, y is minus 1. Like that. So this is a sort of graph that you're actually going to have. Okay. Sort of graph that you're actually going to have. But, okay, we are not done yet. But this graph is going to be traversing, whenever t is minus 2, it's going to be traversing from this point. X is 5. X is 5, y is minus 3. X is 2, y is 0. X is 5. Y is minus 3. Let us check this out. Okay, so you need X is 5. Y is minus 3. Because to X is 2. Y is 0. X is 2. Y is 0. So it's going to stop here. X is 2. Y is 0. Can make it red. So you have this. So it's going to do this. It's going to exactly do that. Because at this point, it's going to run from X to X is 2, Y is 0. So we're going to have exactly that. Going to have exactly that. Any question? So this is what you have. Any question? So that is what you're going to have. Let's check the next question. Ah, okay, the next question is B. So we're done with this one, but now there's a small change here. State a parametric representation of C. C, it's this one. State the parametric representation of C with the orientation reversed. So the orientation, you can see that it is from 5 to minus 3, so it's traversed clockwise. It's traversed clockwise. But if you then, because it's traversed from 5 minus 3 to 2 and 0. All right. Right. Okay. We need to state the parametric, the parametrization, parametric representation of C with the orientation reversed. So now if you reverse the orientation, then you actually, because you look at it the other way, right, you look at it the other way. Let us look at that particular question. So look at 8b. Which means that x is t squared minus 2t plus 2. Okay. Okay, now, okay, so, okay, let us look at x equals t squared minus 2t plus 2. Rather, okay, that would be the fact that if you reverse the parameterization, rather with the orientation reversed, you reverse the orientation. C itself has two of this. We know that for C, x is y squared 2y plus 2 from 5 minus 3 to 2 and 0. So you can decide to say x is t squared 2t plus 2, y is minus t. Y is minus t. Y becomes minus t. Right. So we continue. We continue. Now, because of this, what then are we able to achieve out of this? Okay, we analyze this. Whenever, so in other words, you can let y be negative t. T squared minus 2t plus 2. So then we have the following. We then have the following. So now state a parametric representation of C with the orientation reversed. You would realize therefore that y is going to be like minus t. So whenever you're able to see that at this point, you'd have from minus, y is going to be like from minus 3 to 0, like this. Y is minus t. And then simplify this, is going to be 3 is greater or equal to t 0. So, right, okay, we have this. Okay, so this is what we have. this is what we have. So you need to state, do not sketch this time around, but just give state. So you have seen therefore that x becomes what? Becomes t squared. T squared minus 2t plus 2. Y becomes minus t, where 0 up to 3. Okay, so think about that. Think about that. But that sort of becomes the answer. 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 Right. Okay. Any question on this parametrization whose orientation is reversed? Right, whose orientation is reversed. Right, so this is the parametric representation of C with orientation reversed. We have seen that we were looking at things from 5n minus 3 to 2 and 0. So y becomes therefore a map from is therefore from minus 3 to 0, and you then have this. So x therefore becomes the same as, if x is y squared plus 2y plus 2, y is minus t, then you'd have minus t squared 2 into minus t plus that, which is t squared minus 2t plus 2. Okay, so that's what we're getting. So this is what we have. This is exactly what we have. Yeah, so any question on this one? Then we can check the next one. Because y, the t would be from 0 to 3. When you divide by negative here, or you multiply through negative, 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 multiply by negative, negative 1, all the amongst these three parts of this particular inequality, the inequality changes direction from less than to greater than. From less than to greater than. Right. Right. Right, 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 right. So we continue. Right. Right. So we continue. Let's check if we have another question. Okay, yeah, you need to find some derivatives at the given point without eliminating the parameter. Let us practice with number 9. So dealing with 9a, for example, x becomes like the square root of t, and this means that t to the 1/2 y is 2t plus 7. Dx dt is 1/2 the square root of t, and then dy dt. Right, so you have dy dt, which is 2 only, because we have differentiating this one with respect to t. Dy dx is dy dt dt dx, which is dy dt is 2. Dt dx, you do the opposite of this, so obviously this one we mean dx dt. So, if you do dt dx is 1 over, it's going to be the reciprocal of this, which is just 2t, 2 to the square root of t. So you have 4 to the square root of t, which is 4. So the derivative is just 4. And then this is the first one. Then you need to get the second one. So you need to get d squared y dx squared. It's d dx of dy dx. D dx. What is dy dx? It's 4 the square root of t, which is d dt. Dt dx. Which is 2 over the square root of t. Dt dx. So d squared y dx squared. 2 the square root of t. Dt dx. Okay, so dt dx would be, you substitute dt dx. It's from here. So now you're able to see that dt dx would be the following. Okay, just 1 minute. Hello, my dear. Nyapila njani, Bapilo? All right, all right. Oh, in 10 minutes time. All right, that's fine. That's fine. Okay, that's fine, I will. Okay, thanks then. Okay, thanks, goodbye. Right, so you have this, and then it's 2 over the square root of t, then dt dx. Dt dx would be 2 the square root of t. So now you have 2 times 2, which is 4. D squared y dx squared is 4. So d squared y dx squared is 4 because d squared of t cancels squared of t. So obviously it is correct to then say we have seen that the dy dt at t equals 1 at the given point, it is 4. So dy dt is 4, but d squared y dx squared is also d squared y dx squared is also 4. So we have solved this particular problem here. Let us look at the next one before we look at the arc length and other things. So let us look at part B now. X is the secant of t and y is the tangent of t. So dx dt is sectan. Sec t tan t. And then dy dt is the secant squared t. So that then is dy dx. Dy dt dx, which is the secant of t tan t. 1 over the secant squared of t. Okay, so we continue, which is we have this one divided by the secant of t, which is the sine of t. So now, this one is dy dx. Okay, let me. Yes, please. Yes, please. All right, all right. Okay, yeah, I'll let you know. Okay, that's fine. Okay, that's fine. I'll let you know now. Okay, I'll let you know now. Okay, thanks, Dan. Okay, thanks. Goodbye. All right, so we continue with these to do everything. So we continue. Okay, just 1 minute. There's something I'm sorting out, and then we're gonna finish this one. We're gonna finish this one. Right. Gonna finish this one quickly. Okay, so what we're gonna have here, okay, this one becomes the dy dt is this. And if that is the case, we need to get, it's become the dy dx, which is this, yeah? Because the tangent is sine over cosine. So the tangent of t over the secant of t, the tangent is sine t over cosine t. You divide by the secant, which is 1 over cosine t, and therefore this is sine t. Right, so we continue. So now you need to do dy dx evaluated at t equals pi over 4, which is the sine of pi over 4. So now, you therefore have to do the following here. Right. Right. Okay, just 1 second. Just 1 second. As I try to speak to this person, and then we're going to finish this off. Yeah, which PP is it on the highway? Yes, is it on the highway? Highway. Or which one? Which PP? Oh, okay. Yeah, all right. Okay, thanks. Okay, thanks. All right. Okay, we continue with this one and want to check if this is the case. Okay. All right. So, all right. So we continue. So now, okay, we're continuing, please. We are going on. I think these things were switched around. Okay, I'm going to rectify that. I think these things were switched around. Okay, I think there's something that was switched around here. Okay. So these were just reversed. So this is dy dt, dt dx. So the dy dt becomes sec squared. Dt dx tan t. Cancel these. And then you have 10t. Because this sec cancels one of them. And this is therefore going to reverse the division. And it's going to make it, whenever you have the secant of t divided by 10t, 1 over cosine t divided by sine t over cosine t, and this is 1 over sine t. So this one is going to be 1 over sine t. Okay, we're still going on. So it comes here and then say, when you're doing the derivative here, so this is dy dx, which is 1 over the sine of t. Okay, and then obviously, yeah, 1 over sine t, and then the t becomes pi over 4. And therefore, it's 1 over the pi over 4, it's 1 over the square root of 2. And this becomes the square root of 2. It's fine. And then now you're going to do the second derivative, t squared y dx squared. dy dx. So the dy dx, what is dy dx? Which is 1 over sine t. d dt of 1 over sine t. Which is d squared y dx squared. So the derivative of this by the chain rule is what? So if you differentiate the sine, the 1 over sine t. Right, so 1 over sine t is going to become what? Sine t to the minus 1. Okay, so then the derivative becomes cosine t. So now, and then you'd have dt dx. So which means that d squared y dx squared. Okay, we are checking this one. Okay, we are going on. So if this is the derivative, then you just substitute everything here. What then are we able to achieve out of this? So the derivative of this is going to be minus this by the chain rule. And then you need to multiply by dt dx. Where is dt dx? Okay, this is dx dt. But dt dx is going to be like 1 over the secant of t, the tangent of t. Like that. So, which means that whenever you're doing this one and you're evaluating it at t equals pi over 4, it is the same as what? Pi over 4, so you put minus 2, and then you put the cosine of pi over 4, and then you put pi over 4, pi over 4. Okay, let's get everything and simplify this. So it's minus 1 over the square root of 2 minus 2, 1 over the square root of 2. This one is 1 over, it becomes 1 over the cosine of that. So it becomes just the square root of 2. In the tan of pi over 4, it's a 1. Like this. So we continue. We continue. We continue to check this out. So this is be minus. So this is going to just become what? It's just going to become the square root of 2 squared, which is a 2, and then 1 over the square root of 2, the square root of 2. And then you multiply by the square root of 2, square root of 2, which is minus 2 divided by 2, giving us a minus 1. And this is d squared y dx squared evaluated it. See what you're getting. Right. So we continue. We continue. So if you do this one, t equals pi over 4. Okay, so the answer therefore becomes minus 1. So d squared y, and that is actually a minus 1 there. What is the last question here? Yeah, I think that this one is a little homework, and then we shall continue next time. Later, it's a little home activity, and then we shall continue later in the day. You let me know when you're free. Okay, we'll just send the recording in the next couple of minutes so that you can pause through it. Okay, because then we can finish the rest of this. Okay, thank you for joining us until later on. Right. Thanks so much and goodbye. Goodbye. Hello, my dear. Yeah, 1 minute because this thing is just, yeah, it is just acting up. Yeah, I'm just requesting and it is, but it is, yeah, I'll let you know. I'll let you know. Okay, thanks then, dear. Thanks, goodbye. All right, yeah, thanks, dear. Yeah, I think that because now there's 10 and then what? Okay. We're almost done. Now we can do the number 9. Right, because it's the same thing. Okay, because you have x equals t plus cosine t, y is 1 plus sine t. You have dx dt, which is derivative of the t, it's 1 minus sine t. Derivative of the cosine is minus sine. dy dt is cosine t. Okay, yeah, so you're going to have exactly that. Right. So now you then have dy dx, which is dy dt dx. So dy dt is cosine t. Dt dx is 1 over 1 minus sine t. Right. Okay. Right. Right. So you then have that dy dx is cosine t divided by 1 minus sine t. So you have cosine pi over 4 divided by 1 minus sine pi over 4. And then if you, okay, let's write at the bottom of this. So this would be 1 over the square root of 2, 1 minus 1 over the square root of 2. Square root of 2, square root of 2 becomes 1 over the square root of 2 minus 1. Right, so if we then say this is the answer, dy dx is 1 over the square root of 2 minus 1, you multiply by the square root of 2 plus, nope. I want to do it properly. Okay, I want to do it properly. So if you have 1 divided by minus 1 plus the square root of 2, you have minus 1 minus square root of 2 divided by minus 1 minus square root of 2, which means that dy dx is minus 1 minus square root of 2 divided by 1 minus 2, which is minus 1 minus square root of 2 divided by minus 1, and this is 1, which is the square root of 2 plus 1. Exactly the square root of 2 plus 1. Right. 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 Okay. Okay. So this is going to become what? It will become the square root of 2 plus 1. So dy dx evaluated at t pi over 4. So now, okay, if you look very careful, that's what we've got. But we have got, therefore, square root of 2 plus 1 is the dy dx. Okay, t equals pi over 4. And then let us do the second derivative here. So this one is going to be the part C one. So now you have unique d squared y dx squared, which is d dx of dy dx. d dx. What is dy dx? Okay, dy dx is this. dy dx, which is cosine t. Dy dx is cosine t divided by 1 minus sine t. So the derivative of the top divided by 1 minus sine t. Which is minus sine t. Which is 1 minus sine t. Which is cosine t. Derivative becomes minus cosine t. 1 minus sine t. So, what is this? This is the derivative of this, and then you multiply it, so it is multiplied by dt dx. So that d squared y dx squared. Multiply the top, it becomes minus sine t plus sine squared t plus cosine squared t. You divide by 1 minus sine t squared. Then you have dt dx. Okay, what is dt dx? Dt dx is 1 over 1 minus sine t. 1 over dt dx is 1 over 1 minus sine t, which is 1 over 1 minus sine t. Which is dx squared, which is 1 minus sine t, divided by 1 minus sine t squared. Okay. And this is 1 minus sine t. So 1 minus sine t cancels out. 1 minus sine t squared. D squared y dx squared. Evaluated at t equals pi over 4 radians. Is 1 divided by 1 minus the sine of pi over 4. One over the square root of 2. So you have this. So you square this, it becomes this, you divide by 2. So you can bring the 2 here, like this. So it is 2 divided by, then you have 2 minus 2, the square root of 2 plus 1. 2 divided by 3 minus 2, the square root of 2. So this is the answer to, the 9C. Let us do number 10. Determine the equation of the tangent line to the cycloid. Right, we have been given the cycloid, and it is given by x equals t minus sine t. Right. Right, so we continue. And then the y, 1 minus cosine t. dx dt is 1 minus cosine t. dy dt is, okay. dy dt becomes sine t. dy dx is dy dt dt dx. dy dx. What is dy dt? It's sine t. Dt dx is 1 over 1 minus cosine t. Okay. So you'd have dy dx, which is like sine t divided by 1 minus cosine t. Let us evaluate this one at t equals 2 pi over 3. Dy dx t equals 2 pi out of 3. 2 pi out of 3. 2 pi out of 3. Okay, what is the sine of 2 pi over 3? The sine of 120 degrees. The sine of 120 degrees is the same as the sine of what? Is the same as the sine of 60, which is the square root of 3 out of 2. And the sine, the cosine in the denominator of 2 pi over 3 is the same as what? Is the same as plus, because that is going to be the cosine of 120. 120 is 180 minus. Plus cosine 60. Okay, plus cosine 60, then is just square root is what? Is 1/2. 1/2. And then this is the square root of 3 divided by 2 plus 1. Now, from metric, y minus y1 is m into x minus x1 is the equation of a straight line. Y minus. What is y? The y is going to be obtained when you substitute the x into this. Substituting this x is going to be 1. It's going to be 1 plus 1 minus the cosine of 2 pi over 3. It's 1 plus 1/2 3 over 2. Okay, even this one here becomes the square root of 3. The square root of 3 out of 3. Yeah. So you'd have 3 out of 2. Yeah. You have that y1 is 3 out of 2, and then you get the x. The slope is 1 over the square root of 3. Then you have x minus. Then substitute there. The t equals 2 pi over 3 into the x, which is 2 pi out of 3 minus the sine of this. Okay, yeah. So we continue. Right, so let me just call this person. Okay, yeah, we'll just finish this off. Okay, just finish this off now. We'll just finish this off now. Just now, just a minute. Yeah, it's LD81. LD81, it's the number. Yeah, L for lady. LD, London. Yeah, London Deep Cloth. Yeah, it's a white polo, VW. Yeah. Yeah, it says arrived. The driver is Joshua. Yeah, because it's L. Yeah, LD, L for London. L for London. You found it. Okay, thanks then. Okay, thanks. Goodbye. Okay, so we're going to have that the slope. Okay, thanks and goodbye. Okay, great. Okay, so this one, so it's going to be a square root of 3 here. Minus x1. So x1 is going to be, yeah, you have this one. This guy. Yes, my dear. Oh, okay. Yeah, because here's the pin. I'll just give the pin now. Yeah, the pin is just 1 minute. The thing is loading. It's 4778. Yeah, 4778 is the pin. Okay, thanks. Goodbye. Okay, so we're gonna have this one here, and my apologies to this person. I just calling, and I had to try and intervene. So you have this one, the square root of 3 minus x1. Yeah, so x1 is gonna be 2 pi of 3 because the x is gonna come from this minus the sine of this. So the sine of this is the sine of 120 is like the square root of 3 out of 2. Okay. So the answer therefore becomes the equation of the tangent line to the cycloid is minus 3 out of 2, 1 out of the square root of 3, and then we have x minus 2 pi out of 3, and then plus the square root of 3 out of 2. Okay. Right. Let me see. What is the next question? Okay, we're right done with this part. So now, if we meet later, we're going to do the next things. Okay, the other part, etc. All right, so I think that it's awesome that we've had this discussion. We're going to send the recording in the next couple of minutes. Recording is coming in the next couple of minutes. Right, and as said already, this one here is like 2 pi of 3 minus the square root of 3 out of 2. It's the x value at t equals 2 pi of 3. Right, we must thank you for joining us. It was awesome having this discussion. Until later on. Yeah, maybe 9 p.m. or in the afternoon 4, something like that. So you let me know there. All right, but we thank you for joining us. Until later on, the recording is coming. Thank you. Take care and goodbye. Goodbye. Bye. Goodbye. Bye.